Without doubt, the greatest puzzle ever to confront the human mind is the universe in which we live. When and how was it brought into existence? For what purpose? What forces mold and control it? And perhaps most important of all, where do we fit into the scheme of things? Here truly is a puzzle of astronomical proportions. Puzzle solving requires logic. Logic becomes profound with the gathering of information. Occasionally, in the search for knowledge, there is a discovery so fundamental it is called a breakthrough. The discovery of radio waves coming from outer space was such an occurrence, and it came about quite by accident. The year was 1930. The place, the quiet little town of Holmdel, New Jersey. At the Bell Telephone Laboratories, Carl Jansky, a brilliant young radio engineer, was assigned to study static interference, which was hampering transatlantic telephone communication. In order to study the noise more systematically, Jansky built a large rotating or directional antenna. He dubbed it a merry-go-round. The antenna was connected to a receiver which amplified the signals. The receiver in turn was connected to a graphic recorder. Working with this ingenious equipment, Jansky was able to locate and identify many sources of interference, such as near and distant thunderstorms. But he also noticed a persistent hissing sound which he could not explain. Instead of dismissing the sound as unimportant, Jansky kept accurate records from which he was able to detect the sound's pattern of intensity and direction of arrival. Gradually, Jansky came to a startling conclusion. The interference was coming not from Earth, but from a direction fixed in space, the direction of Sagittarius in the Milky Way. Newspapers carried the account of the discovery, but no one seemed to sense its real importance. So Jansky's reports were filed and forgotten. In 1937, in Wheaton, Illinois, another amateur radio enthusiast, Grote Reber, began experimenting with what he called cosmic static. Intrigued by Jansky's earlier reports, Reber decided to find out more about these strange signals from the Milky Way. To do so, he realized he would need a better antenna, one with more directional capability than Jansky's. This, he felt, could best be achieved by building a parabolic reflector. So Reber constructed what was needed in his own backyard, on his own time, with his own money. His 31-foot dish was the world's first radio telescope. And for several years, Grote Reber was the world's only radio astronomer. He confirmed and enlarged Jansky's findings. He discovered the Milky Way, our galaxy, was like an enormous radio transmitter. By analyzing his findings, Reber was able to put together the first radio map of the Milky Way. Today, his telescope is still in use at the National Radio Astronomy Observatory near Green Bank, West Virginia. In the few short decades since World War II, radio astronomy has exploded in fantastic growth. Literally hundreds of radio telescopes have been designed and deployed around the world. Many of these incredible instruments weigh thousands of tons and cost millions of dollars. They are so versatile they can be used to track satellites, bounce beams off the moon, and pick up signals from the outer reaches of space. The instruments may vary in size, but large or small, they're made up of three basic parts: a reflector with a receptor at its focus, a receiver, and a recorder. The reflector collects radiation from the region of the sky to which it is pointed. The receiver amplifies and measures the radiation, and the recorder produces a permanent record of the observation, usually in two forms simultaneously: on a graph and on magnetic tape. But for all their power and precision, you may still be wondering why radio telescopes play such an important part in our attempts to understand the universe. Well, to answer this question, we need to become familiar with the electromagnetic spectrum, and that's not as difficult as it may sound. All matter in the universe radiates or emits energy. The electromagnetic spectrum shows the scope or range of this energy, both in terms of its frequency and its wavelength. At the lower end of the spectrum, the wavelengths are long. At the upper end, short. The narrow white strip represents energy we can see with our eyes and is therefore called visible light. The radio section of the spectrum is a range of wavelengths 10,000 times greater than that of visible light. Attempting to understand the universe by using just the visible light section is like trying to understand baseball by watching the action through a crack in the fence. By contrast, radio astronomy has opened a huge window to the universe. Looking through this window, we are discovering things we didn't even know existed. For example, radio telescopes revealed a strong source of radiation in the constellation of Cygnus. Star maps showed absolutely nothing at that particular position. So coordinates were sent to Mount Palomar, and the powerful 200-inch optical telescope was pointed at the spot from which the radiation was being received. For several hours, it tracked an apparently empty section of the sky. A photographic plate was exposed. When the print was developed, the astronomers realized they were looking at something they had never seen before, something they would never have known even existed except for radio astronomy. A galaxy undergoing a violent explosion. They called it Cygnus A. The Crab Nebula is the result of another dramatic event. It was once a star which came to a violent and spectacular end. For 6,000 years, the light from the explosion traveled through space and finally reached the Earth on July 4th, 1054 A.D. It was observed by Chinese astronomers. To them, it was a new star which glowed more brightly than Venus in the early morning sky. In fact, according to their records, the new star could be seen in broad daylight. For 23 days, it was the brightest object in the heavens except for the sun, and then it faded and disappeared. Today, when we point our telescopes to that place in the sky, we see the starkly beautiful Crab Nebula, the expanding remains of that guest star once observed by Chinese astronomers. In the center of the Crab Nebula is a small but extremely dense object, a neutron star, a pulsar. In 1967, working together at Cambridge University, Professor Anthony Hewish and his assistant Jocelyn Bell picked up a signal from outer space that pulsed with eerie regularity and for which they could not account on the basis of anything known to astronomy. Because the signals were coming in short bursts or pulses, the new source of radiation was called a pulsating radio source, or pulsar for short. Since that historic moment, over 100 pulsars have been located, all thus far in our galaxy. It is believed they are formed from the collapsed remnants of supernova explosions. They are extremely dense. They have intense magnetic fields and small diameters, only about 12 miles or even smaller. But 1 teaspoonful of a pulsar would weigh 700 million tons. At such a density, the Earth would be only 432 feet in diameter. And the Earth's entire population could be squeezed into a single drop of water. As they rotate, pulsars seem to generate beams of directional energy that sweep out across space like a lighthouse beacon. As the beam hits the Earth, it appears on electronic equipment as a pulse. It has been suggested that pulsars might be used as navigational beacons in space flight. But out there in space, beyond the pulsars, even beyond the galaxies, are other celestial objects recently discovered through the window of radio astronomy. To the best of our knowledge, these objects are the most distant things in the universe. They are called quasars. The word quasar comes from quasi-stellar, something that looks like a star but isn't. What is a quasar? We do not know. What we do know is that quasars are the brightest and the most remote objects known to man. The Milky Way has 100 billion stars, many of them brighter than the sun. But according to recent estimates, 1 quasar is 200 times as bright as the entire Milky Way galaxy. Whatever they are, quasars seem to be at the very edge of the universe, traveling away from us. And the farther away they are, the faster they seem to be traveling. In fact, the entire universe seems to be expanding, all of which supports the theory that at one time, every bit of matter and energy in the universe was concentrated in one place. In other words, there is strong evidence to support the belief that the universe had a definite beginning. Now, if the universe did begin with a cataclysmic explosion, the radio waves from that explosion should still be in existence. They would be of predictable wavelengths and intensities, and they would be uniformly distributed throughout space. Radio waves meeting those requirements do exist. The task of science is to take all the bits and pieces of information which come from every area of research and fit them into a meaningful whole. It's very much like solving a puzzle. Radio astronomy is playing a vital part in helping to solve the puzzle of the universe. The farther out into space we look, the farther back into time we go. As scientists compare the here and now with the there and then, they find that no matter how far into the past their findings take them, the same physical laws seem to apply. Over the mantel of the fireplace, outside the office Albert Einstein occupied at Princeton University, are these words: God is very subtle, but he is not malicious. Einstein would have us remember that it takes tremendous effort and dedication to understand something as complex as the universe. But we can come to that understanding because of the order, the unity, and the harmony we find there.